Hello.
My name is Alfonso Fernandez, and this is the second video of the two dedicated to the characterization of water bodies using satellite images. Now we are analyzing optical sensors. Some considerations are made regarding the differences between inland and coastal water bodies. We will see the spectral fundamentals of the response of water at different wavelengths, considering the components that influence it. This is followed by some water indices that can be used, followed by a conclusion on sensor types. And as a continuation of this presentation, a video tutorial is available with a practical exercise using a Sentinel-2 image. The behavior of water areas is different for different wavelengths. Whether the spectral bands are analyzed separately or in combination. In bands such as green or red, the absorption of water is not very strong, while in the near-infrared or short-wave infrared bands the absorption is remarkable. This allows combinations of bands with the infrared to facilitate the task of identifying and delimiting areas covered by water, as in the case of the reservoir shown in this example, differentiating them from other areas such as forest vegetation or crop areas. In coastal areas, another effect of great importance appears when separating water from land. This is the existence of foam in the area of breaking waves. Foam that in certain spectral bands appears with high radiometric levels, as can be seen in the false color combinations using the red and near-infrared bands. In other infrared bands, SWIRN and especially SWIRTWO, this effect is less evident. So these bands contribute a lot of information to the segmentation process. But what variables condition the response of water and therefore its color, as can be seen in the figure? Atmospheric processes of absorption and scattering, the geometry and angles of observation, the amount of illumination incident, the characteristics of the water surface itself, i.e., substances on the surface and their roughness, and very important, the composition and optical properties of the water column, suspended matter content and turbidity, the amount of algae and vegetation, dissolved or suspended organic matter, as well as the reflection of energy from the bottom. The figure on the left shows the spectral response of the different components identifiable in the water. Suspended sediments generate the strongest response in both the visible and near-infrared. In contrast, both chlorophyll and dissolved organic matter contribute less to the amount of energy received by the satellite, being limited almost exclusively to the visible spectrum. The image on the right shows how water with different amounts of suspended silt has spectral responses directly proportional to these amounts, with the maximum being shifted towards longer wavelengths. It can be concluded that analyzing the response of water allows us to obtain the composition and properties of the water's constituents, and even its depth. Traditional segmentation methods are based on the use of water indices. Most of these indices are designed to generate negative values for pixels with no water and positive values for pixels with water, so the standard threshold used to separate them is 0. Some indices can be seen in this table, such as the normalized difference water index and the modified normalized difference water index, whose expressions involve the green, near-infrared, or shortwave infrared bands. The next two indices, ONCH and OISH, use the SWIR bands in shadowless and shadowed images respectively. The bands involved in their calculation and the equations relating them are shown in the table. Other indices are designed not only to delimit water bodies, but also to identify other characteristics that they present. This is the case of the NDPI, designed to analyze the amount of vegetation, or the NDTI, created to study water turbidity. This figure shows the behavior of 5 of the aforementioned indices in an inland body of water, showing that the OISH index is the one that best allows the segmentation. Other indices, such as NDTI or NDPI, do not allow such a clear delimitation. applying the indices of the previous exemplito, a coastal environment that also has a large lagoon. It can be seen that the OISH index generates a good result for delimiting the water. The other indices can be used for other purposes. It should be noted that if the aim is to delimit the coastline, there are two indices whose behavior is not optimal. NY and NDTI indices. They are affected by the effects of waves. As a conclusion to the two videos presented on the identification of water bodies, this table presents a comparison of certain properties of optical and radar images, depending on the objectives pursued as well as the possibility of access to remote sensing products. The user must analyze the advantages and disadvantages of using optical images or radar images. The results shown above have been obtained using the SNAP software. In the video tutorial called Practical Exercise of Water Bodies Detection with Sentinel-2 in SNAP, you can find the detailed process to obtain a binary product. With the list of references used in the preparation of this information, this video ends. Thank you very much for your attention.